So today we're going to start 7.6.4, so the second half of chapter 6. And we're going to talk about some more practical applications for using percents. So percents, parts, wholes, being able to find each of those things in sort of practical applications that you would see every day. So let's start with a couple definitions. So percent of change is what it sounds like. It's the percent a quantity changes from the original amount. So if you have an original amount of something and then it gets more, then that's an increase by a particular percent. Or if you have a certain amount of something and it decreases, then that is a decrease by a certain percent. So the percent change formula, overall, sort of the basic overview of percent change is that the percent change is equal to the amount of change. So however much a quantity goes up or down, that amount of change over the original amount. Percent increase gets a little bit more specific. It's a type of percent of change. But in this case, it's what it sounds like. A percent increase happens when the original amount increases. So you start with, a particular amount of money, and then maybe it increases because it earned interest, or, you had a job and you made more, and then the percent of your money increased. That's a percent increase. We find percent increase by taking the new amount, because that is going to be more, right? So if you started with $60 and you were given $15, now you have $75. You take that new amount, which is more, $75, minus the original amount that you had, $60, and you divide it by the original. So the new amount for percent increase, the new amount minus the original amount, and then you divide by the original amount. That will give you a decimal, and then you change it to a percent. Percent decrease is going to be the opposite. So you start with an amount of something and then it decreases over time. So percent decrease is a decrease from the original amount. And the formula for percent decrease is that you take the original amount, subtract the new amount, and divide by the original. So again, it will be a decimal, and then you will change that decimal to a percent to get the percent decrease. In both of these, the key is you always take the larger amount and subtract the smaller amount. So with percent increase, the larger amount is the new amount because your original has gotten bigger. It's increased. With percent decrease, the original amount is the larger amount because over time, it's decreased. So originally you had more before it went down. So you always take the larger amount, subtract the smaller amount, and then divide by what you had initially. Okay, so let's do an example. It says the table shows the hours you spent online last weekend. So here's our table, and then it shows the day of the weekend and the hours you spent online. 2 hours on Saturday, 4.5 hours on Sunday. And then it asks, what is the percentage of change from Saturday to Sunday? So if we look at this, first of all, we can see that the percentage of change is going to be an increase, right? Because we went from 2 hours to 4.5 hours. So if we look back and look at our percent increase formula, percent increase is going to be equal to the new amount minus the original amount over the original amount. So our original amount was what happened Saturday, right? Our 2 hours on Saturday was the initial amount, and we're comparing that to the new amount, which is the 4.5 hours on Sunday. So then we just can plug in to solve. So percent increase equals the new amount, 4.5, minus the original amount, which is 2, over the original amount, which is 2. Okay, let's simplify our numerator. 4.5 minus 2 is 2.5. Divide by 2, and we get 1.25. So remember, when you finish this and you do your division, you plug in, subtract, whatever, you end up with 1.25. But that is not our percent, that's our decimal. So remember, we always take that decimal and we move our decimal place to go from a decimal to a percent, move 2 places to the right, and add the percent sign. So our percent change was an increase of 125% from Saturday to Sunday. All right, let's look at example 2. Another sort of real world applications using a real world example. This one has a bar graph showing a softball player's home run totals. So you can see over on this side, we've got each year. Okay, so 2015, 16, 17. And then we have the softball player's total home runs in that year. Okay, here's what the question asks. What was the percent change from 2016? So we're going to take that 28 home runs in 2016 as compared to 2017. So looking at this, we can see that from 2016 to 2017, this player had a decrease in home runs. So this is going to be a percent decrease from 2016 to 2017. So if we recall, percent decrease is going to equal the original minus the new over the original. Okay, because we always take the number that's larger, subtract the number that's smaller, and then divide by the original. So let's plug in. Our original is 28. Our new amount is 20, so the later year, 2017, she only got 20 home runs. And divide by the original amount, which is 28. Simplify your numerator. 28 minus 20 is 8. Divided by 28. Okay, and when you do this, you end up, it gives you a like a long decimal, kind of an irrational, not irrational, but it gives you a long decimal. So it's 0.285714, and then it kind of keeps going. So that's not our percent. I should erase that. That's our decimal. To make this a percent, if you get this on your homework, it will tell you where to round to. So let's first start by moving our decimal. Typically, it'll have you round to the tenths place. So if we move our decimal, we get 28 point. And then if we round to the tenths place, we look to the right. 7 is greater than 5, so we're going to round that 0.5 up to 0.6 and put our percent symbol. So her home run total decreased by 28.6% from 2016 to 2017. So when you get a long decimal number like that, just make sure that you read the instructions as to where they want you to round it to. You will be given instructions as to where to round. Okay, maybe they'll tell you to round the nearest whole number. In that case, it would be 29%. So just pay attention to rounding instructions if you don't get a really simple, straightforward answer. All right, the last thing we need to talk about is percent error. And percent error is a percent that an estimated amount differs from the actual amount. So this is used in applications where you're trying to guess something, or you're making a judgment about how much of something you put in or took out versus how much there can be. So let's look at an example. I think it'll be easier with the example than me trying to make my own example up. So we find percent error. Let me just sort of highlight this more clearly. Okay, this is how we find percent error. Percent error is the amount of error. So whatever the difference is between the given amount or the estimated amount and the actual amount, so the amount of error over the actual amount. It will be a decimal, and you'll change that decimal to a percent to get the percent error. Amount of error will always be a positive number, so if you get a negative, you need to check your math. We always write percent error as a positive. So for example, it says you fill bags with about 16 ounces of homemade dog treats. So this is where we're going to get percent error, because basically you're estimating what's about 16 ounces. You're not measuring it, but you're sort of putting in what you think is about 16 ounces of homemade dog treats into bags. The acceptable percent error when filling a bag is 5%. So as long as you're within 5% of the percent error of that 16 ounces, you are okay. Like the company could use those bags or whatever. Those can be sold or whatever is the parameters around it. So it needs to be within 5%. Tell whether each bag is acceptable. So we've got two bags, bag A and bag B. And let's do these both separate. So let's do this one first. Okay, bag A is 15 ounces, and it needs to be at 16 ounces. So the difference between 15 and 16, if we do 16, the needed amount, right, it needs to be 16 ounces, but you were an ounce off. So minus 15 over the amount that we needed, so the actual amount. And then we subtract, so we get 1 over 16 and turn that into a decimal. 0.0625. From this decimal, we can find the percent error. 1, 2, move our decimal place 2 places to the right. So this is 6.25% error. Is that acceptable based on what we were told in the question? The answer is no, because it says the percent error must be 5%. This is too big of an error. This is more than 5%, so you are too far off. So bag A, you probably need to add a little bit, right, to get it closer to that 16 ounces for it to be acceptable. Versus bag B is 16.5 ounces. So we'll figure out how far 16.5 is off of the actual amount, the needed amount of 16. So 16.5 divided by 16, subtract 16 and then divide by 16, because that's the actual amount you need. Okay, so then we get 0.5 divided by 16. And that gives us our decimal. This one is 0.03125. And then we need to take that decimal, turn it into a percent. 1, 2, move 2 places to the right, add our percent sign. So this is 3.125%. So is this acceptable if it needs to be 5 or less? And this would be yes. 3% is less than 5%, so that bag is close enough to the actual amount that would be okay. It would be acceptable to be used or sold or whatever they're going to do with it. Okay, so that's how we're working with percents today: increase, decrease, and percent error.